Let's get started. So I want you to imagine the next big killer application. An application that is on everyone's mind. Everyone is speaking about it, not only technical people, but also management people. Everyone wants to have it. Everyone spends a lot of money. People even purchase expensive new hardware to get it. And this killer application is called VisiCalc. Indeed, VisiCalc back then was the first so-called killer application for the home computer market. It was developed in 1979 for the Apple II and later ported to other environments. And it was really something that was completely new for a lot of people out there. Spreadsheet was not that known. Before, people had some scripts calculating stuff. But suddenly you had a visual tool that allowed you to calculate things. And only by changing one cell, everything was recalculated automatically for you. This was a huge game changer for people in offices. It allowed you to do calculations, but also what-if scenarios. And the rumor was that people actually purchased the Apple II, not because of the Apple II, but because of VisiCalc. And of course, since then, the environment evolved quite a lot. The way how we do applications, how applications work, evolved quite a lot. And nowadays, this evolution headed towards chat. And now you say, oh no, I don't want to chat all the time. I want to use a real application. Do we really have to chat? This does not make sense for me. And the answer here is, well, to chat or not to chat, that's the wrong question, as my good old friend William said. Because at the end of the day, when it comes to agentic UI, it's not about chat versus not a chat. It's more about this here, catching the user's intent, getting to know what the user wants to do, what the user wants to achieve, and trying to achieve this in a more or less autonomous way. This autonomous way consists of a loop which is re-executed time and again until we figure out, well, now we are done. Now we have really reached the goal of the user. And this involves also tool calling. Calling this tool to get more information here, calling that tool to get more information there. So at the end, it really starts with the user intent and not with the question, do we like to chat or not? And when it comes to the user intent, indeed, there are several ways to catch it. It really depends on your situation. For instance, you might just go with something like a natural language query, where you describe a report and then you get the report like something here, a dynamic chart or something like this. Or perhaps sometimes you want to describe a dashboard and then you get your entire dynamic dashboard. Then you don't see this prompt anymore, you just see the dashboard until you change it. Or another possibility would be to upload a document. Here a passport, but it also could be, let's say, an invoice or some other document, and then some processes are triggered. Here we are pre-filling the form. In other situations, you might trigger your payment process. Is the invoice justified? Do we have to pay it? When do we have to pay it? Is it correct? And so on and so forth. Another way we could catch the intent of the user is a mixture of structured data and unstructured data, like here when it comes to a travel planner, where I fill out I want to go from A to B, but I have some special requests, like a stopover in Paris for dinner. I mean, who is not doing this when flying from A to B, stopping over in Paris to get some dinner? It's a good idea, isn't it? And here we see it's not only my free text preferences, it's also an entire process to get to my goal. a process that runs in the background and that sooner or later tells me, well, this here would be a nice travel plan fitting your requirements. Everyone who needs to book travels on a regular basis, flights and fitting hotels and so on, knows that this can be quite extensive and quite a burden and would value something like this. And last but not least, there is something like chatting, of course, but when it comes to a chat, there are several possibilities. The simplest possibility is just answering a question, free text. This is what you often need in customer support. But sometimes you need more. Sometimes, like here, you want to answer with a structured component, a component that gives you some interaction. Or sometimes the chat might remote control parts of your application, route you over to the right location. And sometimes, because of using the chat, something in the working area is constructed. Perhaps your travel plan is refined, or your ads campaign is defined and updated just by entering this and that into the chat instead of clicking here and clicking there and clicking over there. So the important thing here is that if you want to get rid of the chat in the sense of a text wall, then you need to end up with something like co-creation, where the result of what you are doing in the chat window is not the chat window, the result is in the main area of your application. Something you are building or just finding the right form and pre-filling it. When we look at such an architecture, we see quite often in the backend an agent that is communicating to tools. Tools performing database queries, finding out about your booked flights, finding out about how to cancel a flight, with which costs it comes, or perhaps sometimes it produces a side effect, like actually canceling or booking a flight. This agent talks to an LLM. It communicates the possibilities of the tools to the LLM, and so the LLM can decide when and how to call those tools. Another thing that is not often explained is the counterpart on the client side. Most books end here. But when it comes to front-end development, obviously this counterpart on the front end is especially important for us. Here we have a counterpart to the agent. I call it UI runtime. And also this counterpart has access to tools. But now we are speaking about client-side tools. Tools that allow you to route over there, that allow you to pre-populate a form, tools that allow you to trigger a search and so on. And besides tools, we have components that can be seen as a special kind of tools, a special kind of tools that are visual, that are displaying something. And also there we have metadata about everything. This metadata is sent upwards to the agent and so to the LLM. And that means the LLM can decide to invoke this client-side tool or to display this and that component with those and these parameters. Some people think about this thing in the backend not as about an agent, but as about an harness. Something that is harnessing the power of the AI. Because the AI, the LLM, is of course powerful, but it is unpredictable. It can hallucinate. We all know it can hallucinate and come up with the weirdest things. That's why we need to guardrail it somehow. We need to harness it somehow with good promptings and checks before we deliver the answer to the client itself. And in this model, everything is the agentic system. But regardless of how you think about this, one thing is always there, namely somehow we need to communicate with the client side. And of course, nowadays we use HTTP for this, but it's not the traditional HTTP you are used to. It's not request response. No, it's more. Because when it comes to AI and LLM, it's more like sending over a request. And then the LLM starts working like the Energizer Bunny, you know it from the advertisements. And then it provides you some progress information because it lasts a bit longer. It says, hey, I'm now thinking about this, I'm thinking about that, I'm invoking this tool, I'm invoking that tool, I'm loading your booked flights, I look up prices, and so on. And this is something you really want to have. Everything else provides fear. If the agent is just working and not telling you, it provides fear. I have a good metaphor for this. I had this dentist. He was really a great guy, brilliant dentist. What he did really lasted in the long term. However, he was not talkative. He was everything but talkative. He did not tell me what he is doing. He was just starting to work in my mouth. I was sitting there on the chair. I had no idea what's going on. This really created a bad feeling. Afterwards it was okay, but it created a bad feeling. And we have the same situation there. So we need to send down progress information. Perhaps the final progress information is something like, please now display this final component with the results we've gotten. That means we need a way to stream down progress, and this can be done with server-sent events or WebSockets, for instance. Perhaps even longballing when we have a bad firewall that restricts SSE and WebSockets. Should not be a big topic anymore. It was rather a topic in the past. Okay, when we have an architecture like this, then there are several questions that come immediately up. One question is how to communicate with the agent. How do this in terms of messages we are sending up and downwards. And another question is how to prevent coupling to the server stack and hence to the LLM. Because in the front end, we are not interested into using semantics of any server-side AI framework. It should not matter whether they are using Spring AI or some Microsoft framework or LangGraph, LangChain or something else. It should not matter for us. We just want to get messages and act accordingly. In general, it's always a good idea to act accordingly. But we don't want to couple ourselves to technology on the server side. And not even to the LLM itself, because we all know different customers might go with different LLMs. We might have to experiment with them when there are new generations and so on and so forth. Another question that comes up once we have answered those questions is how can we now support dynamic UIs as an answer from the agent? Really dynamic AIs, not just display this component, but a dynamic answer like, hey, I have now constructed this UI surface for you with this item and this widget and that button. This is my answer. Really dynamic UI the LLM is constructing for us, going far beyond just selecting one of 5 possible components. And all those questions is the purpose of this session. I'm going to answer them, and for this I have just prepared 2 things for you. The first thing is about the communication with the agent. It's about AGUI, which is a emerging protocol that really solves exactly the question how to communicate. And the second thing is A2UI. It sounds similar, but it is something completely different. It's a protocol for constructing dynamic UIs in your LLM. Before we start, let me introduce myself. I'm Manfred. I'm a trainer and consultant for Angular, and I'm focusing on Angular in the enterprise. In this role, I'm helping a lot of customers for more than 10 years now with Angular trainings, with consulting, with reviews and development. Besides this, I'm also quite connected to the community. I live in Austria. I do a lot of stuff in Germany, and I'm always happy to work together with people around the globe. We have several customers, for instance, also in Poland. And after this session, I'm traveling to Belgium to another event. Okay, cool. So let's get started with the first question. How to communicate with the agent and how do this in a way to not couple ourselves to the framework in the backend, regardless whether they are using Spring AI, LangGraph, or something else. It should be the same for us. So, as you can imagine, for this we need another protocol that loosely couples everything on the backend. We need a protocol that is abstracting the server stack, that is abstracting the LLM itself, that provides event streaming so that we get progress information, and that is transport agnostic. Some people might prefer server-sent events, other people might prefer something like WebSockets, for instance. And the good news is there is already a protocol like this. It's AGUI. AGUI is the Agent User Interaction Protocol. And there is even an SDK for AGUI, an SDK that allows you to quickly get started with it. Because usually we don't like to implement the protocol bit by bit. No, we want to have some first implementation. And when it comes to the core implementation for TypeScript, meanwhile, you see it here, we have over 700,000 downloads a week, which is not nothing. But one thing that is even more important is the slope here. You really see a quite rapid adoption in the last month, which tells a lot, which really tells that people are picking this and using this for their applications more and more. And this is only the SDK for TypeScript. Besides this, we have support for a lot of other frameworks. Here you see a lot of frameworks, each and every framework for AI on the server side that is mainly used nowadays, like LangGraph, Crew AI, the Microsoft Agent Framework, Google ADK, Mastra, Spring AI, and so on. And here you see a lot of SDKs that are supported. So some of those SDKs and framework adoptions are just using the official SDK, and some of them bring their own. For instance, Microsoft is implementing their own implementation of AGUI for .NET, for C#, and so on. Let me show you a demonstration for all of this. In this demonstration, I have here my simple example application that has implemented several agentic use cases like dynamic reporting. Here I am defining what I want to see, and after some thinking, I get this very report. Here another report where I will quickly tweak the prompt in 1 minute. This is about delayed flights and flights that are in time. So here I see, okay, 2 flights have been delayed and 5 flights are in time. So let's add here, give me percentage. And now we should see the same using percentage values like 28 and 71 should add up to something like 100%, respecting the comma values. Okay, so this is one use case. Another use case is this travel planner we've seen before, where I can say, let's go from Graz to Rome, and I want to have a stopover in Paris. This takes a bit longer because in this scenario, I'm delegating a lot of work to the AI. It's always a trade-off. You can delegate less work to the AI, then the AI is more in your harness. Then it only can do things you have foreseen. Or you can delegate more work to the AI, then it takes a bit longer. It is, but also a bit more flexible in terms of the results it comes up with. And yeah, here we have some results with a stopover in Paris. Okay, cool. Now let's talk about this assistant here. Let's assume I'm a person who does not know whether they have booked a flight. I know this sounds a bit crazy, but when you are traveling a lot, sometimes you don't even know anymore. Did I book this flight, or did I just discuss it with a colleague, or did I just look up the prices? So let's ask it, did I book France? A flight for France. And now it's thinking, and then it comes up with a good answer. And look here, this answer is really nice. It tells me, yeah, you have booked to France, namely Paris. So because of its world knowledge, it knows that Paris is in France. And it shows me this here. And in order to show me this booking, it was triggering a tool call on the backend. A tool call that was loading the current user's flights in the future. So this is more than just a chat. I get a real answer. I can say now check in, and here we are. I can fill out the form or upload my passport. Here the passport of Jane Doe with some number, issue date valid. All this stuff airport companies want to know about, and it's always a burden to type it in. No, not again this valid until date, but you see it here, everything was typed in for us. So let's go on here. Search for flights from the metropolis of Graz. Perhaps you know this huge city in the southeast of Austria, to Madrid. And here you see, we changed the route. This form was pre-filled, and even the search button was dragged. So one more time, the result is not the chat itself. The result is the main working area. And of course, everything works also without this chat window, this assistant. But if the user is lost, they can use it, or if the user thinks now typing in one sentence is easier to clicking 20 times, then they can also use it. Okay, now let's have a look at the protocol level. Here I'm opening my network tab, and let me answer the same question again. France booked. Caveman encoding. Saves you a lot of tokens. Just speak like a caveman to the AI. Yes, France is booked. So let's have a look here at the protocol level. So what we see here is I have a post message, and in the payload we see my question, France booked. And also here I'm providing information about my client-side tools, like get loaded flights, or like find flights, or show components, show this, show that, with a lot of metadata. Metadata that also consists of a JSON schema that describes the parameters of my tools and the inputs of my components. So if we look into find flights, here there is a free text information, but regarding the parameters, we have a JSON schema telling the AI, hey, you can provide from and to, both is a string, here you have a description. So this was the request. And when it comes to the answer, we are getting several events streamed down, like run started, like, hey, I'm starting working for you now, like executing a tool, starting a tool call, providing arguments for this tool, or finishing a tool call. And then we are starting with the results of the tool call and another tool call. Here, in this case, the first tool call is about finding the booked flights of the user. The second tool call is a client-side tool call. It's about telling the UI to display this widget with the flight we have seen before. So let's have a look inside of this, because, you know, as the ancient Romans said, in codex veritas. So for this, let's have a look to this first message to get a feeling for AGUI. Let's save this, temp.json. Let's format this. Let's increase the size. So this is how HUI looks like. We have several messages of several types that are well defined. Each and every type, like tool start, has some data. And here tool start says, well, I'm starting the tool called find booked flights tool. Find booked flights tool is a server-side tool. It's about fetching data. We do it obviously on the server side. And here we also have a tool ID, something like epsilon set yamda yamda yamda. So now let's have a look here to the next message. We are providing some arguments for the tool call. We are saying the tool call is done. And when the tool call is done, only the tool call is done, the call. They really take the term call very literally, because after the call has been done, execution starts, the energizer rabbit. And then this tool on the server side, orchestrated by the agent, returns a tool call result. So let's have a look into this result. No? Wrong window. Don't save. Let's have a look into this result. Here we go. Let's have a look into this result. So what we see here is, well, it is a result for our tool call, epsilon set, hamda, hamda, hamda. And here we see some content, also JSON. So we got the flights of the current user with the ID, one, with Graz, Hamburg, with this date. We really have to be fast to catch these flights. Could be a bit of attention there. And there is another flight that goes from Hamburg to Graz and so on and so forth. So this is the result of the tool call that is sent back not only to us, but also to the LLM, so that the LLM can decide what to answer. So that the LLM can say, yeah, in your 3 future flights, there is 1 flight to Paris. So after that, the agent and the LLM decides to trigger another tool call. This tool call is for show components. So the LLM decided to not just answer with plain text, but with something that's visual. Another tool call, now a tool on the client side. And for this tool call, we have arguments. It's always a good idea to have good arguments. Let's have a look to this. Tool call arguments. Please display these and those components on the client side, a message widget with a property text that says, yes, you have booked a flight to France, Paris. And then there is a flight widget to display with those properties. The flight with this ID, 390, Graz, Paris, and so on and so forth. Which exactly results into this. Yes, you have booked a flight to France, Paris, Graz, Paris, 390 is the ID, and so on and so forth. So when we think about the implementation level of this protocol, of course we have this SDK, this HUI SDK we have seen before that is downloaded a lot recently. However, for application development, obviously, this SDK is too low level. We need to think of something on top on this. We need to implement some convenience functions. And this is what I did for this example. And this is also what I would recommend to you, because your code should not deal with low-level stuff. So let's have a look into my implementation, just to give you an idea of how I abstracted this. So what I have here is a so-called resource. A resource allows us to communicate with the backend. This here is Angular specific, but it would look very similar in all the other frameworks. So in general, everything I'm telling you here works with all the possible frameworks, because we are more on a conceptual level, even though I'm an Angular guy. So this is my resource for communicating with the backend. We are providing an URL. we are providing some other metadata and some tools. And when it comes to the tools is just a bunch of metadata with a name, with a description, and for the parameters we have a SOT schema. A SOT schema telling the backend, the LLM, hey, if you want to call this client-side tool, give us from and to, both are strings, and here you have a description. This is exactly what you have seen before in the payload, what we send that up to our agent in the backend. And this is also why we are using SOT here, because SOT, perhaps you've seen it, it's quite a popular library in TypeScript for defining schemas, allows us to convert all of this here to JSON schema. But not only to JSON schema, because it's that well known, there is also a nice bridge to TypeScript. So we can derive TypeScript types from this. And this is also something I did here in my abstraction of the SDK. This execute method takes arguments, and those arguments have exactly the same shape, from and to. And if I change this here, the JSON schema will be changed, but also here TypeScript knows that suddenly it's called, you have seen it, from 1 to 3. So we are kind of type safe here. Besides this, we are just triggering functions, services we very likely already have in our client. Function services for navigating over to a different route, or perhaps we want to tell a store to do this or that. Here we are telling the store responsible for searching for flights to update its filter with from and to. Both is sent down from the agent, from the LLM. And so the store, one more time, Energizer Rapid starts loading this data. It will display the data in this very route here. So this is the glue code, usually delegating to some pre-existing stuff. And here you see it's a good idea to have a store in your client, because usually the store is a headless version of your application. It can do what your application is capable of, but without any AI. UI, hopefully with AI, but without any UI, so headless. Okay, when it comes to the components, it's quite similar. Also for the components, we have a description, a lot of text, the component itself. Here it's an Angular component. In other environments, we might point to a Vue or React or Svelte component. And also here we have a schema describing the inputs, the properties of the components. Because just selecting a component to display is only one side of the coin. We only need to define what to display inside of the components. That's why we have to populate properties, and those properties are described here. We have to pass in a flight and a status. And the flight is another SOT schema. Come on. Another SOT schema that says, well, it's just an object with those properties and those data types, and here you have some descriptions. And one more time, as also this is converted to JSON schema, the LLM can find out when and how and also whether to invoke this component on the client side. Okay. Once we have implemented something like this, the next question is, well, how can we go dynamic? Like dynamic, not just selecting a component, but constructing everything on the server side in the LLM. For instance, like in my dashboard I have shown you before. Just a bunch of information, and then we get our dynamic dashboard. Well, this is exactly where A2 UI comes in. A2UI is a protocol developed at Google, and it has some nice characteristics. One characteristic, of course, is constructing dynamic UI on the client side, on the server side for the client. But another characteristic is, and you see it here, it works across web, mobile, and desktop. So it's not bound to just your single page application. It is intended to work everywhere. And also this was an important design criteria for Google. It was always important for Google. I'm doing a lot with micro frontends, where this is also a huge topic. They don't want to execute foreign code in your application. So they don't want the LLM to construct JavaScript code that is executed in your frontend on the fly. Because, you know, never trust the model. Who knows what the LLM is coming up with? Might be okayish in 10 times, and if you execute it once again, it completely messes up. So the idea here is that your client is communicating with the agent is communicating with the LLM, and the LLM answers with an UI surface, a JSON description of your dynamic UI. And this can already be A2UI or a minimum DSL, shrink down to what you actually need. Dealing with flights, dealing with delays, something like this. So this is up to you. And this is also, once again, this trade-off. If you give the AI a bit more freedom, it is more flexible. You can cover more unexpected use cases, but it takes longer, it consumes more tokens, and it can mess up more easily. Or on the other side, you harness your LLM, you just allow it to produce a minimum DSL, and then it has not that much possibilities. It can only do pre-thought things, but it is faster, less token consumption, and it cannot mess up that easily. So this is, in general, a big trade-off. But regardless of this, at least when it comes to the communication with the client, we are answering with A2UI. And this is what it looks like. It is just a bunch of components. Several JSON fragments, sometimes even several JSON documents describing another part of your UI. Those are really separate documents because we want to stream them down little by little. But all those documents together form a component tree because they are referencing each other via IDs. And there are even already some pre-existing components in there, like the text component I'm using here. The text component that is actually displaying text in different shapes. There is a way to tell the component to display a title, first order title, second order title, or just a body. But one thing that is more interesting here than displaying text is where the text comes from. Sometimes the text might be inline, hard-coded in this fragment here. And sometimes this text might be the result of a data binding. Look at this. How cool is that? The people at Google even baked in data binding in this lightweight protocol. So you can say, hey, in some seconds you get a passenger, and please display his or her name here. This has the huge advantage that we can cache this. We don't need to reproduce this time and again from our LLM. And if the passenger to display is changing, we just have to send down this data package containing our passenger, and it will be automatically updated in the UI. So really, really smart. When it comes to renderers, well, everything that is important should be covered. Not everything, but I think the most used frameworks out there, React, Lit for web components, Angular, Flutter, Android support is planned, and at the end of the day, everyone could write their own renderer for further technologies. So you could implement a renderer for, I don't know, your terminal window, or for WinForms, or for something like iOS. So it's really up to you if you want to have it. This all has some nice characteristics. One characteristic is no foreign code. You don't execute foreign code. You only get the structure and you have to visualize it. And there is a clear separation between the structure from the LLM and your rendering. That means you render it according to your design system, according to your design language, your colors, your font sizes. It should not feel alien in the middle of your UI. And by the way, you can even define some events this generated UI is emitting, and then your client can act accordingly, doing this, doing that, when there is a check-in event or a search event. Let me show you all of this in practice. So for this, I'm going over to my, of course, next branch. Let me start my backend again. Let me start my front end again. Now we have dashboard. So there is a first dashboard that describes a dashboard from the view of someone who works at the airport, who needs to supervise some flights and there are delays. Here we have even some diagrams generated, which are just images. Images that are displayed by the image control that comes via AGUI. Everything else here is baked into AGAI, like tables or images, titles, and so on. And here we have another dashboard from a passenger's perspective that shows you the boarding passes for the next 2 flights, or a list with all the booked flights, or here the possibility to rent a car here or there, or hotels, or the weather forecast. This component here looks a bit prettier, and the reason here is that it is a predefined component. It does not come directly from A2UI. It is implemented on the client side, and we just send up metadata to the agent. We told the agent, well, as part of your AGUI surface, you are also allowed to render this card here. Just give me this name and those properties like airport of departure, airport of destination. I will do it for you. So it's really highly extensible. And to go full circle, I want to show you how this looks underneath the covers. Let's request this guy again. So what we have here is one more time AGUI, the first topic, the first protocol. And as part of this, we have several tool calls. You can imagine to get all this data here, we need to trigger some tools. For each and every dial, we have a tool. And at the end here, we have an activity snapshot. An activity snapshot, and yeah, it's quite huge. But here you see, it's one more time AGUI. We have an activity snapshot. Just give me a second. AGUI, activity snapshot, it's an A2UI surface. And now we are talking in the content of this, we have all those operations defined by A2UI, like, that was a bit too much, like create a surface, create an empty surface, or update the surface with this and those components, or update the data model with those tickets here. So later, when the tickets are changing, we just have to send down update data model with the changed flight, and that's it. So this is where both standards come together. And just to tell you that this is dynamic for my next 3 upcoming flights, bang, 1, 2, 3, now it has been extended. Okay, so if you like this topic, I'm currently writing this book on this entire topic. It will be released very soon. Now you know what I will do this summer. Well, huge parts are already done, and there is this waiting list under agentic-angular.com, so sign up there to get notified if you are interested into this. agentic-angular.com. Okay, so let me come to a conclusion. What did we see today? So in the first part of this talk, we talked about what agentic AI and UI is about. And first and foremost, it's not about whether we like or hate chats. This is an easy discussion. But the real discussion is how to catch the user's intent, how to find out what they want. And sometimes it might be a chat, sometimes it might be something completely different. And even when it's a chat, there are several possibilities up to co-creation, where the real result happens in the main window, and the chat is just one possibility to trigger actions there. It's about autonomy, and it's about tool calling. Client-side tools, but also server-side tools. We've talked about standards. AGUI is the backbone for the communication, because we want to loosely couple to our server stack. We don't want to be dependent on server-side technologies. And A2UI is this shiny new technology from Google that allows an LLM to construct a completely dynamic answer. And regarding the tactics, well, it's all about describing your stuff with schemas. Most people nowadays use SOT, because SOT can be converted to JSON schema and sent upwards to the LLM, so that the LLM knows what to trigger on the client side, what to invoke in terms of tools, what to invoke in terms of components, also what to invoke on the server side in terms of tools. So it's all about schemas, and it's about processing messages. Messages telling us about textual answers, widgets to display, and tools to execute. And last but not least, there is one last thing I want you to do now. So if you go out there now, please think about one last thing. Now think about how to create the next killer application, because now we have the tools, so go out and catch it. So that's it. Thanks for having me. Here you already have my contact data. I've already uploaded all my material, slides and examples to my blog, and follow me on social media to stay in contact. Thank you.